potential is denoted by letter psi. This water potential is the movement of water in the system. This psi of water potential is equals to solute potential plus pressure potential plus gravitational potential. So, we are having this viscous water potential meter, or we can also say psychrometer. So, we will discuss about in brief, then I will tell you step by step that how we can operate it and how to calibrate it and how we can measure reading in different biological samples. So, viscous water potential is a specialized psychrometer which is used for measuring water potential in leaf disc or in any soil sample. It is basically very important tool or very important trait which is useful for researchers for measuring water potential under a stressful environment and non-stressful environment in any of the biological samples. This water potential uses thermocouple hygrometry to measure water potential or psi of any biological system or soil sample. Basically, it is designed with C52 chamber which house the thermocouple sensors and have samples housing in it. This device measures the dew point temperature of the air equilibrium with the sample from which water potential is calculated. So, the basic principle of this water potential which is denoted by psi is directly related to relative humidity which is RH. So, this psi is equal to RT upon Vm to natural log of RH, where R is gas constant, T is temperature and Vm is volume of water, and this RH is relative humidity. Two components of this water potential. As you can see, this is the main unit of water potential. Here we are having this display where we can record or note the readings. Here we are having this electronic devices where we can assemble all our chambers and thermocouple wires. These are basically the sample chambers, or we can say C52 chambers. In these C52 chambers, we are having sample holders. In this sample holders, we will place our leaf disc or any of the biological sample or soil samples. We are having, these are basically thermocouple sensors. Basically, these sensors do sense that wherever water vapor, or we can say these sensors do calculate the water potential, that what is the dew point of this particular leaf disc or any sample. These are the cleaning solution and calibration solution which which we are using to clean the solution and calibrate the solution, calibrate our water potential. So, working principle of this water potential, we are having viscous water potential. So, it operates basically on the principle of thermocouple hygrometry. So, what is this thermocouple hygrometry? This is a technique basically which measures water potential by assessing the relative humidity and dew point depression in a sealed C52 chamber. So, the process begins with a sample preparation where a small biological or soil sample such as a leaf disc or stem segment or soil pores are prepared, and they are placed under C52 sample chamber, and these are specialized airtight compartments. I'll show you this how this airtight compartment works. Just this is the basic principle of it. So once the sample is inside this chamber and the chamber is sealed, initiating the equilibrium phase. So what is this equilibrium phase? Basically, during which the water in the sample exchanges moisture with the surrounding air. So once water vapors are created, obviously, allowing the water pressure to stabilize at a level that corresponds to water potential of a sample. After equilibrium, what happens? Cooling phase begins. So whenever the cooling phase begins, there is an electric current which is applied to thermocouple junction inside the chamber. This causes thermocouple to cool down below the dew point temperature, leading to condensation of water vapor onto its surface, and hence the readings are calculated or noted here only. So the next stage is the measurement phase, where we can calculate the reading as thermocouple detects, and we can record the reading by, here on the display. Readings will appear and we can record it easily. This difference is direct function of sample's water potential, as the relative humidity inside the chamber is governed by moisture content of the sample. As I have told you earlier, that basically water potential is the movement of water within the system. So what water is moving, and after condensing what we are getting, that is calculated under this water potential meter. Finally, the calculation phase, the potentiometer processes these temperature readings using psychrometric equation. As I have told you earlier, what is the psychrometric equation? That is psi is equals to RT upon Vm to the natural log of relative humidity, which relates the dew point depression to water potential of segments in megapascals. So readings here are recorded basically in megapascals. The instrument provides a precise and reliable measurement, allowing researcher to assess water stress plants, soil moisture level, and overall water dynamics in any of the biological samples. So what are its applications? As you are all are doing particular this GYAN course, so you all know that why you are doing this, what are its uses. So basically its application is, it is used to measure water potential in plant tissues under stressful and non-stressful environment. It determines soil moisture potential in irrigation management. Apart from this, it also evaluates seed hydration level for germination studies. It assists plant water relation in physiological research, as water plant relation is very much important in plant physiology and stress physiology. It also monitors water status in forestry and ecological studies. It supports agricultural research for optimizing water use. It aids soil sciences for understanding water retention and movement. It also helps in post-harvest physiology, and it is also useful in environmental studies. So its advantages are, as it provides accurate and reliable water potential. It is non-destructive method, as it preserves sample integrity. Thirdly, it is highly sensitive to small changes in water potential. Even a minute change, it can record it. So it is highly sensitive. It is portable. As you can see, I have bought it from lab to here, so it is portable device. Rapid equilibration and measurement process work across a wide range of biological samples. We can use any kind of leaf sample. It can record its reading. Apart from this, it requires small sample size. So not much biomass or not much sample is needed to record its reading or to record water potential. Helps in real-time monitoring. Means we can record, suppose I have to take readings today only. So today we can measure it easily. We do not have to wait for 1 week or 1 month to take reading. Okay? So now I am telling you step-by-step procedure how to use it. First of all, this is the main unit. Can everyone see it? Okay. So I have connected its charger. Firstly, we have to switch on it. As you all know that we have to switch on it. These are basically C52 chambers, and these are wires, thermo wires, and this small thing here is sample holder. As you can see that in this sample holder, we are having a small depression. In this depression, we have to place our biological sample or soil sample, whatever you like. Is it clear? So a thing which is important is this, that we are calculating water potential. So firstly, we should clean it. Cleaning, then calibration, and thirdly, then we have to take our sample and record the readings. Is it clear? So for cleaning, we are having here cleaning solution. This is provided by Wesker only, cleaning solution. So what you have to do here, firstly, you have to attach this thing with main unit. In this main unit, you are having 1, 2, 3, 4, 5, 6 serial wise number. So this one is chamber number 2. So you have to connect this chamber number 2 with the main unit. Then chamber number 3, you can see it. Then chamber number 3, chamber 4, and lastly chamber 5. Once these chambers are connected, you have to make sure that the sample holders are connected to it and it is sealed or not. For sealing, what you have to do, it's very easy. Just you have to slide it. You have to place your sample holder and slide it backwards. Now it is sealed. If you have to tightly seal it. If it is not tight, then reading will not come. Readings would not be accurate. So, for cleaning, as I have cleaned it already and calibrated, but I am showing you that how to clean it. Just you have to pour cleaning solution along with these small tissue papers or tissue discs. These are also provided by Vescos only. So in this sample chamber, I have placed this disc. This is the cleaning solution. You have to pour a small amount of this cleaning solution in this, and then you have to seal the chamber. It is sealed, then you have to switch on it. As you cannot see it from there, but in 10 groups I'll show you. Then you have to go to number 2 of this, and there you have to wait for at least 85 seconds for 2 minutes. Then it will clean it, and then we can further proceed for our experiment. So as I have already cleaned it, so we'll move further. What you have to do, again, whenever you are opening this seal chamber, you have to switch off it. Or you have to switch off it from here. There are 2 options, either from here or from here, but you have to switch off it. Neither your calibration will be disturbed. Okay? So it's very easy. You don't have to take it out. Just there are these provided. You have to just insert it in it, and your tissue papers with cleaning solutions are. Now what you have to do, as I have calibrated it already, calibration is also very easy. For calibration, we are having this deionized water. Or we can also use NaCl water, it's totally up to you. We have to place this deionized water in all the 5 chambers or 8 chambers, it totally depends on you that how many chambers you are using. If you are using 5, then in 5 chambers you have to place this deionized water. Then at least for 1 hour you should wait. Now how will you know that this is calibrated? Readings will be optimized. At all level you will get same water potential reading, because you are putting same solution. You are placing same solution in all the chambers. Clear? Now moving to our experiment, as I am having 3 different kind of leaves of tomato, and similarly 3 different kind of leaves of wheat. This one is control, as it is having only distilled water. This one is hormone treated, and this one is treated with stress. Similarly, in wheat also control set or control leaf, and this one is hormone treated, and this one is treated with stress. So you all know that in stressful condition, water potential drops down. Okay, and whenever we are treating it with some hormone or with some regulator or whichever thing which is acting as stress mitigator, it increases water potential. but that water potential should be 1 or below 1. Okay, this thing is clear. So it totally depends. If suppose of control we are having water potential 0.6 and is in stress we are having water potential 0.3 say. So in hormone treated we can either get 0.8 or we can get lesser than control. It totally depends. This particular hormone treated is hormone treated plus stress. Clear? So now I have already cut a small disc of this leaf sample. So very meticulously you have to place these discs in the sample chamber. Tightly I have seal packed them. I have kept placed samples in it. Again I am switching on it. Then I am now I have basically noted here on I have gone on option 2 and there we can calculate water potential. So here are different readings, but only we have to note or we have to record water potential which is in megapascals. So for after 85 seconds we'll get reading of this sample 2, then of 3, then of 4 and so on. So you can come in group of 10 and record readings here. This one here is basically for water potential megapascal for reading of water potential. ठीक है, यहाँ पे जो है देख रहे हैं, यहाँ पे सेकंड वेट कर रहे हैं, यहाँ पे जो है तुम जब नीचे करोगे नहीं दिख रहा होगा ना, बहुत लाइट दिख रहा है, ये ऊपर की लाइट बंद करा दूँ। देखो अभी यहाँ पे 0 आ रही है, ठीक है, 0 इसलिए आ रही है क्योंकि सैंपल 1 में कुछ नहीं है, ठीक है, अभी आएगी ना, वो टाइम वेट करूँ। CGR plus stress. वो इसके अंदर है। देखो यहाँ पे रीडिंग्स चेंज हो गई, 0.7 ही आने लगी है ना, यहाँ पे भी चेंज हो गई रीडिंग। तो दिस इज डिमार्केटिंग कि यहाँ पे जो है सैम्पल रीडिंग्स जो है चेंज हुई हैं और ये तुम कैलकुलेट कर सकते हो। यहाँ पे रीडिंग्स एग्जैक्ट इसलिए नहीं आ रही क्योंकि वाटर में डिप था, तो ऑलरेडी वाटर पोटेंशियल बहुत हाई आएगा क्योंकि वाटर में वो डिप है। अगर तुम बायोलॉजिकल सैंपल से वैसे नोट करोगे तो ये चेंज आते जाएगा। देयर इज द टाइम, यहाँ पे टेम्परेचर है, यहाँ पे तुम लोग रीडिंग्स नोट कर सकते हो। ठीक है, ये सैंपल चैम्बर है। ठीक है ना, 5 में अभी नहीं डाला। सैंपल को निकालो यहाँ से। सिंपली और कुछ नहीं करना। ठीक है ना, क्लियर। यहाँ पे रीडिंग आएगी है ना, यहाँ पे ये भी रीडिंग है, ये चेंज हो रही है ना हर थोड़ी। देखो -2 आ गई क्योंकि, और यहाँ पे देखो यानी 3, यानी ये चैम्बर 3 की रीडिंग। चैम्बर 3, ये यहाँ पे जो है टेम्परेचर, कितना टेम्परेचर है, ठीक है, ये आ गया तुम्हारा वाटर पोटेंशियल इज -2। ठीक है, ये WBD है, इससे हमें मतलब नहीं है, ये बेसिकली डिफरेंट पैरामीटर्स है जो कि ये निकालते हैं। क्लियर। अब बस नेक्स्ट ग्रुप। अच्छा, ये नीचे वाली ना। हम्म हम्म कंट्रोल में देता हूँ तो 5 तो सबका तो वाटर पोटेंशियल अलग होगा ना। ठीक है, नेक्स्ट ग्रुप। आइए ना, फोटो ले लेते हैं। You just have to take a look at setup. It will not get, you will not learn it only one use or just by demonstrating. Firstly, you have to learn how to assemble it, as I have already told you. Main thing is assembling. Readings which you are record basically which you are noting, or which this particular water potential is measuring, uh, is totally dependent on whatever sample you are using. Suppose I am having this stressed plant leaf, but I have cut this small slices 1 or 2 hours ago. So obviously there will be hindrance in reading. Water potential, it might give water potential reading correct, or maybe it will not give water potential reading correct, as I have already cut this slices 1 or 2 hours ago. You have to take a fresh sample of fresh leaf disc, and that leaf disc should assemble in that chamber holder. They should neither be too large or too small. देखो अब यहाँ पे 0.04 आ रही है, किसकी आ रही है, 5 की आ रही है, यानी 5th वाले की ये आ रही है 0.04, जो कि आ रही है यहाँ पे, ये जो है हाँ मेगा पास्कल। टेम्परेचर क्या है, 22.8 डिग्री सेल्सियस। ठीक है, लॉग बेसिकली ये सब क्या है, जो हमने अभी इक्वेशन पढ़ी थी जिस पे ये वर्क कर रहा है। मेन रीडिंग ये है 0 पॉइंट, देखो दे रखा है ना वाटर पोटेंशियल मेगा पास्कल, ये बता देता है। हाँ हाँ, कौन से वाले इसका। अब ये 5th नंबर का चैम्बर है, तो ये 5th नंबर की रीडिंग है। दूसरे चैम्बर का एक बार देख लिया, खत्म। एग्जैक्टली। ये बेटा ये अलग है, मैंने बताया था ना उसका पूरा जो फॉर्मूला होता है जिस पे वो वर्क करता है, ये पूरा वो है कि वाटर कितना है, ये पूरी कैलकुलेशन है। मेन जो ये चीज़ बता रहा है ये बता रहा है, एल एन बताया था मैंने, ये एल एन है, ये टेम्परेचर, इससे कुछ मतलब नहीं है। मेन रीडिंग ये है वाटर। ठीक है ना। अब देखो
से ओपन
ये इसका 25 डिग्री सेल्सियस पे ऑलरेडी फिक्स है। अब मेन यही है, इसको निकालो, इसको लगाओ, मेन इसकी असेंबली है।
अच्छा ये जो है इसी के अकॉर्डिंग होगा, जो प्लेन मार्किंग है ना, तो ये वही मार्किंग यहाँ पर
2
होगी।
3 4 5
और एक यहाँ पे ऑन होगा, आपने किधर किया होगा?
ये वहाँ से स्पीकर्स लगे हुए थे कि इतना यूज़ हुआ है कि ये हट गए हैं स्पीकर, तो ये हमने मार्कर्स किए।
और अपनी दूसरी जगह से कहाँ से ऑन होता है या आपने
ये यहाँ पे नीचे करके पूरा, फिर रीडिंग्स वो हो जाएंगी फ्लक्चुएट। नीचे से यहाँ से वो करो,
सबसे
यहीं से
पहले
ऑन
आप
ऑफ कर दो, यही
सबसे
सही
पहले
है।
आपने वो जो
इस
आपने किया
सैंपल
है
होल्डर से निकालूं, ठीक है,
हम्म,
इस सैंपल होल्डर को रखो,
हम्म,
बंद कर दो, सिंपल,
फिर वो रीडिंग ले
वो
लेगा।
रीडिंग ले लो।
अभी तो आपने हटा रखा है,
ठीक है
अभी
ना।
फिफ्थ वाले की दिखा रहा है,
फिफ्थ
उसमें
वाले के
उसमें
अब हो
लगी
गया
हुई है।
पूरा, फिफ्थ वाला आ गया, यानी अब ये पूरा एक राउंड हो गया, आ गई fifth वाला।
सही बोल रही हैं आप, ये कई बार कराने के बाद है ना सही।
नेक्स्ट प्रूफ।